So can you see the full screen?
Yes, perfect. So everything okay? Shall I get started with it, Mithileysh?
Oh yes, please go ahead, Noor.
Thank you. Good evening, everyone. Hope you all are keeping well. I'm Noor, one of the organizers and chair at IEEE University of Melbourne Student Branch. Welcome to the technical session on Design Study Methodology for Healthcare Industry 5.0, jointly being organized by IEEE University of Melbourne Student Branch, IEEE EMBS Victorian Section Chapter, IEEE Monash University EMBS Students Group, and Society for Medical and Biological Engineering, SMBE Victoria. A bit of housekeeping stuff before we get started. This is going to be a 45-minute talk followed by a 15-minute Q&A session in the last. If you have any queries during the session, please use the Q&A window to type your questions. You may also raise your virtual hand available at the bottom tab at the end of the session so that we can unmute you if you like to ask your questions directly. Or we are also happy to include all the attendees as the panelists for an interactive discussion during the Q&A session. For any other queries, use the chat window to write to the organizers during the talk. Okay, let's now focus on the theme of today's event. We are having Dr. Mithileysh Sathiyanarayanan, who is tech trainer and scientist at MIT Square, London. As I said before, he's delivering talk on design study methodology for healthcare industry 5.0. This talk will primarily focus on IoT and AI-based human-centric solutions in healthcare. Most emphasis today is on practical case studies and potential pitfalls on industry 5.0, which is mass personalization of healthcare for the new normal post-COVID. I'll give a very brief overview of the speaker, Dr. Mithileysh. Firstly, he's an Indian-born research scientist and entrepreneur based out of London. He closely works with Make in India campaign initiatives. His expertise in technology research, both theoretical and application levels, ranges from industrial projects to academia like education, engineering, and healthcare. He holds a PhD from City, University of London, and a pre-doctoral fellowship from the University of Brighton, UK. His research was in collaboration with Nuclear Research Finland, which won him Young Scientist Award. Congratulations on that. Dr. Mithileysh has around 50 plus referred publications, invited talks across the globe, internationally recognized projects, and patents to his credit. Without any delay, let me hand over the session to our esteemed speaker. The session is all yours, Mithileysh.
Thank you, Noor. Thank you so much for the kind introduction. This is really great of you. And it's a great pleasure for me to be here and to give a talk on health industry 5.0, which we are trying to think ahead next 10 years what's going to be health industry all about. And thank you so much for this wonderful invite. Let me quickly dive into health industry 5.0. Before we try to understand what is healthcare 5.0 or health industry 5.0, it's wise to understand what is industrial revolution all about and what is health industry revolution. So industrial revolution is nothing but a very simple interaction between human and a machine, which makes life easy, which makes work better and quicker. So we have almost like 4 generations in the industrial side, that is from industry 1.0 to 2.0, 3.0, 4.0. Now slowly we started moving into 5.0. I will walk you through all the revolution that has taken place over the last years. Currently, Industry 4.0 touches all the latest technologies such as big data, cloud, augmented reality, extended reality, robotics, cybersecurity, blockchain, and so on. IoT, of course, the artificial intelligence. So it can be a combination of multiple technologies, or it could be just a single technology that could make a complete revolution. In the Industry 1.0, we call it as more like a production stage. So where the focus was more on the mechanics. One of the classic example is steam engines. That was maybe in 1740s, I guess, I'm not very sure. Maybe it's around 1780s or 1810, I guess. And most of the strategic decisions was just to make some mechanical kind of systems that could help a human work much easier and better. Slowly, people started moving into 2.0, that is nothing but industrialization. People started thinking more in terms of electrical units that could be plugged into the mechanical systems. So that's where we see more of a mass production in the industrial side. And most of the examples are electrical machines that came into existence. From there, we moved on to 3.0, that's nothing but automation. there, the focus was on electronics and computers. That's where we started using computers to connect with the mechanical systems. And again, the strategic differentiator is nothing but the mass automation. Most of the systems started becoming automated. You just feed in some values, give some kind of inputs, and then the system tries to act on behalf of you and behalf of the human. So technically, the human operations were minimized. Then slowly we started moving into the digitalization. That's nothing but Industry 4.0. And the focus is completely on cyber physical systems, which includes IoT, artificial intelligence, robotics, and other smart devices. Here, the focus is completely on the mass customization for individuals. So some of the examples can be smartwatch, where we use Fitbit kind of system for your health tracking and health analytics. So that's one of the examples of Industry 4.0. Now the interesting bit comes. That's nothing but Industry 5.0, where people started working on the personalization. So from mass customization to mass personalization is what we are trying to work on. Most of the industries are in the same lines, especially in US, Australia, Canada, Germany, of course UK as well. So people started focusing more on the Industry 5.0 now. It's more like a customer centric, and some of the examples could be super fast manufacturing sectors. They would be, of course, a bit of a human intervention. With human intervention, you need to provide some kind of inputs to make it completely personalized, so especially in the manufacturing sectors. So nothing can work without human. So of course human will play a massive role, but in terms of including active learning part in artificial intelligence or something of the sort, so you need always a human intervention to make sure everything is going smooth. So this is completely on the industrial level. Now, so health industry, again, it started with 1.0 as a production stage. So the focus was completely on the evidence-based treatment model. Once the patient gets into the hospital, so everything was completely based on the evidence. They try to do some kind of research, and then they try to come up with some kind of drugs or medicines. And the most important strategic differentiator here was patient survivability. At the end of the day, the goal was to make sure the patient survives. That was completely in the healthcare 1.0, again, something in 1800s, I guess. Slowly, we moved into healthcare 2.0, which is completely industrialization. And the focus was on value chain integration model. So once the patient steps into the healthcare, they made sure the patient undergoes all the stages to make sure the patient recovers completely. So it's something called as end-to-end service coverage. So patient was monitored at every stage. And from there, we are moved into the healthcare automation, that's 3.0. And they started focusing more to improve the quality, efficiency, and the cost as well. So it focused more on the operating models. From there, now we are somewhere near the 4.0. We are trying to hit the balance between 3.0 and 4.0. Completely, we are not moved into 4.0. I can call it as 3.5 maybe, because we are trying to hit the balance between operating model and the business model. Again, it's completely on the mass customization. And what I'm going to talk about is like healthcare 5.0. Here we are going to focus on a particular individual. It could be a healthcare professional, or it could be a user, or it could be a patient. Again, to improve the quality of life, to understand a person's health, how it behaves, how it behaved in the past, how it's behaving, and how it can behave in the future. So it's like past, present, and future. I will walk you through the couple of slides so you'll be able to understand what I'm trying to say. So healthcare or health industry provides a product to the customer as per their specific requirements. So now we are in a stage where each individual wants to have a solution or a product that can be completely customized or bespoke based on his or her requirement. Now the complete focus is on healthcare professionals and patients in the health industry 5.0 to improve in terms of health analytics. It could be quality of life, it could be well-being, lifestyle, wellness, so on. So how are we moving from healthcare 4.0 to 5.0? We have Apple's products which are trying to use latest technologies like AI, which can predict high blood pressure and sleep apnea. This is going to be completely personalized. So that's again part of 5.0. And Google recently purchased DeepMinds, which is aiming to change the way we diagnose and treatment. It can be in hospital also. I guess it can be personalized, and the person can use it at home as well. I think they are still working on it. Amazon is trying to work on the telemedicine applications and also medical supply chains. And I am sure these are going to be highly disruptive in the coming years. What I personally see is, this is just my observation, so maybe I'm wrong or maybe I'm a bit off, right? I'm not sure. Well, most of the work are done at a base where academic research is quite strong, but unfortunately, the translation from the academic research to healthcare and then with the industrial collaboration doesn't happen. There is some kind of gaps which I have observed. If we want to see the success of healthcare 4.0, I strongly believe there must be three-tier collaborations. So definitely academic research plays a massive role in terms of doing the exhaustive research, and healthcare professionals have to be part of the whole research, whatever the academic people are doing, and of course with collaboration with industries in terms of setting up the platforms, or it could be setting up of the solutions or deploying some other solutions. So I believe all the three are massive stakeholders in any of the projects that we'll be taking up from here. So let's see how I'm picking up one of the examples that we are trying to work on. So it's completely on the healthcare analytics, which is going to be completely personalized, which could be completely personalized for a particular individual. It could be a healthcare professional or it could be a user. So though we are in the industry, we always start something with the research question. So I always believe, since after my PhD, I believe always starting something with a hypothesis, research question, followed by aims and objectives. So I generally follow this model even in the industry. So we started thinking to what extent visual analysis or visualizations can support patients, users, or healthcare professionals in finding relevant or interesting information in their own personal data. So that's a very high level research question. And the overall aim is to design and develop interactive platform that can be personalized to explore and find relevant or interesting information in a personal health record. So let's say a person has a complete history that can be accessed from the hospital or from his local clinic. So he has a complete history from the day that he stepped into the hospital. It could be in terms of his normal health conditions, or it could be a cancer, it could be some other conditions. So it helps an individual to really understand what has happened in the past for him, what is currently happening, and it can also predict what could be a potential risk that it might be carrying in the future. So that's what we are trying to personalize, and still it's in work in progress. So I'll give you a bit more details, in a couple of slides. As I mentioned, again, I try to project my industrial work more in terms of academic research. So I started coming up with certain objectives. First, we try to understand the healthcare domain, and we try to collect some literature review based on the personal analytics and using visualizations. So that was objective 1. And in objective 2, we started designing and developing interactive visualizations. And the third objective was to validate the visual methods, whatever we try to develop. And the fourth one was more of an iterative development that went into a cycle. And currently we are in the fourth stage that we are trying to make it much better and very niche kind of product. Now let's see what is design study methodology and how this can fit into healthcare 5.0. So design study methodology was developed and proposed by Tamara, Professor Tamara in US. So she uses this for any of the sectors. It could be for healthcare, it could be for engineering, it could be for agriculture. So wherever you use visual analytics or personal data, so they use this kind of a design study methodology where you have collaborators from the industries, from academic, and of course the stakeholders for a particular domain. This is a 9-stage model. So we start with something called learning, followed by winnowing, casting. So learning is nothing but understanding the literature, or it could be understanding the initial, the domain itself. And in winnowing, you try to winnow and get the right collaborator, because you cannot just have a collaborator just for the sake of having from a particular domain. You need to have the kind of expertise for that particular problem and that for a particular domain. So that's nothing but winnowing. So you try to filter down the collaborators. It could be from the academic, it could be research scholars, it could be the industrial collaborators, or any other stakeholders for that matter. And casting, you try to define the roles. It could be experts, non-experts, industrial collaborators, principal investigators, scholars, PhDs, students, interns. You give them different roles. So we call it as casting. That's nothing but a precondition phase. It's always good to do within a couple of months or 3 months maximum, or in some other cases it could be a very long process because you need to learn and understand the domain. So it depends completely on the researchers to do it. But when you see it as industry, we always allow to push it a bit quicker. And from precondition phase, we move into condition phase, which is nothing but a core phase. In the discovery stage, that's the fourth stage, you start understanding the domain a bit in detail. You start characterizing the domain, you start characterizing the problem, you start characterizing the tasks, you start coming up with the analytical goals. And then once you understand the whole thing, you might conduct interviews with the experts. You capture all the informations. It could be challenges, limitations, it could be positives, opportunities. So that forms the discovery stage. Then the fifth stage, you start designing the solutions, especially for the healthcare analytics, what I'm talking about. So you need to definitely design. You need to come up with some prototypes. You start with some low fidelity prototypes, then you move on to medium level prototypes, then the high level prototypes, and then you start implementing them. It could be using the latest technologies like, it could be D3, for example, data driven documents. So that's the latest technology that industries are using, D3 platform. And that's the implementation stage. From there, you move on to the deployment stage. That's nothing but the seventh stage. In the deployment stage, once everything is set up and then you have the complete prototype, you deploy it in a particular platform. Let's say it could be Amazon, it could be Google platform, or it could be any other collaborators platform, or a healthcare platform as well. That's the seventh stage. And the eighth stage is the reflection. So whatever you have developed so far, you have characterized, you have designed, you have implemented, you have deployed, and then you start reflecting on it, whether the things that you have done is it in the right way, or you need to make some changes, or if changes, what exactly you need to do. Discuss again with the collaborators. So the model is completely iterative. So you start with the stage one, then you start working on it. From stage one to stage two, you go back, you try to iterate over, make sure everything is good. Then you go to the third stage, again, you look into the stage one and stage two. So that's how it keeps going. It's a completely iterative stage. So you start with precondition, then you move to core, and then you start analyzing. And the last stage is nothing but the dissemination. So you submit in a conference or a journal, or you apply for patents, and that's the final stage. So this is what I quickly mentioned in terms of three phases. That's the precondition phase, condition, and the post-condition. And for this model to work successfully, you need to have real-world problem, real users, and the real data. So this DSM can be a perfect fit if you have these three as a main criteria. And for each of the phase, as I mentioned, you have different activities that can be performed. In precondition phase, you have understanding of the domain, conducting the regular interviews with the experts and non-experts, establishing the aim, objectives, research questions, literature review, state of the art technologies, and coming up with some key findings. So that forms precondition. In the condition phase, again, you characterize the domain, come up with regular interviews, translate the design requirements into analysis goals and tasks. You start designing and developing the solutions based on the analysis goals and tasks. And the third phase, as I mentioned, you will be conducting again the interviews. It can be evaluation, it can be validation, it can be reflecting on the designs and the evaluation. Of course, if it's a PhD, you'll be doing it as a thesis writing, or if it is industrial work or any other collaboration, you just try to disseminate it as a report. So that completes the whole three stages or three phases, in fact. Let's get a bit into the DSM, what we are trying to do for our project. So we call it as precondition phase. As I mentioned, it's phase one. We have three stages: learning, winnowing, and casting. So in stage one, we started understanding the domain, as well as we started understanding the visualization features. The moment we captured the healthcare data, we understood we had three to four types of features. So one is the temporal feature, the other is the individual, the content, and the thread features. So in temporal, it's about the patient's timeline or a history that the person had started from the past. Like it could be his history, like what exactly happened at one point of time. It could be in the morning, evening, or it could be at late in the night. So at what point he was admitted in the hospital, or what point he was diagnosed. So those things forms as a temporal feature. As individuals, it's about which are the individuals that have given attention to him. It could be nurses, it could be other healthcare professionals or doctors, consultants. So those people are individuals, and the contents are nothing but the management plan, like what exactly the patient have to take up for his conditions. It could be for a cancer, like how we need to take up the medicines or drugs based on the prescription of the doctors. So that forms the content. And it could be the other history as well, like how many times he has been coughing, or what other particular health conditions he has. Everything is being documented, and everything is being made as a digital data, and that's where the data we try to capture and we try to analyze. And the fourth feature is nothing but threat feature. It's very interesting feature. For example, let's say a person has a cancer, so you start understanding a person history in a complete threat format. So at some instant of point, something happens, then the doctor documents it, then the patient attender or someone tries to give that kind of attention to the patient, and they try to update their informations. Then again, the consultants continue to keep updating and keep a track of the patient's records. So that forms as a threat. So this is something very interesting thing that's going to be in the future. We call it as a threaded history or a threaded patient information. And the other thing we started understanding is the visualization techniques that we need to implement to make it as a real personalized solution. After surveying a lot of papers, we understood it's better to use conventional kind of visualizations. The reason is not all doctors are really tech savvy to understand complex kind of visualizations or complex kind of diagrams. So we started analyzing. So it's much better to use basic charts and basic matrices. Basic charts are nothing but a heat matrix or bar charts, line graphs, and so on. And visualization tasks and interaction systems are one of the other things that we try to understand as well. So most of the solutions so far based on industry 3.0 4.0, we see a lot of solutions, but it's not completely personalized to in our observation. And they do have something called we expect something like an overview, which is of course there, but we don't have something called details on demand. The moment you click on some particular item of interest, so you need to have some kind of a pop-up which gives you a better information. It could be for a healthcare professional or for a patient. And so I think those things are missing in the current solutions. And patients are not able to explore the data itself. So that's another drawback as well. So this is something we learned in the first stage. So in the next stage, we strongly believed it has to be definitely collaborated with the healthcare professionals, followed by academic researchers and the industry collaborators. And this is how we started working. And we started giving them, of course, we try to winnow in terms of understanding each one's expertise, domain, the skill sets that they bring to the table. And we started casting them. So we started giving them some particular roles. So how they would act. A healthcare professional, we try to give him the tag as a cardiac consultant. So we started defining each one's roles and responsibilities. So the moment we wanted to validate a particular result, so that particular individual will come into the play. And moving to the condition phase, that is phase 2, we have again 3 stages: discovering stage, designing, and the implementing stage. So in stage 4, as I mentioned, this stage is very critical. The reason is you need to really understand the design challenges for healthcare 5.0. You need to characterize the problem. You need to abstract the problems. In terms of abstracting, we identified 3 design challenges. That is the one of the main design challenge was finding interesting conditions within a large data set. Because most generally you will have a massive data set in the healthcare, especially if you're a healthcare professional. Particular patients' data could just keep growing enormously over a period of time. So navigating within the data, identifying some interesting conditions, or identifying some of the subsets of a particular patient's history is not very easy at all. So that's one thing we observed. And the second thing is the complete healthcare patterns are quite complex and dynamic, and it keeps evolving over a period of time, right? So it's quite complex. So that's one of the second challenges. The third challenge, as I mentioned earlier, is about exploring the data. If the healthcare professional wants to navigate within the data and identify some interesting conditions or patterns, then it's not going to be easy. easy. You need to really observe all the past, present, and also analyze what could be in the future. So we need some kind of a super good visualization technique that can easily, serenely navigate through the whole process. That's another challenge that we observed and we identified. So this form.
Pardon interrupting, you're getting a bit muffled on occasions. I think you're brushing against the microphone.
All right. So is it okay now?
Yeah, it's good now.
All right. Okay. So yeah, this was, I mean, this completely forms the discovery stage. That's nothing but the fourth stage. Here we identified 3 challenges, right? So the 3 challenges helped us to discover. That's moving into the stage 4. It's nothing but the discovering stage. That's nothing but characterizing the data and characterizing and abstracting the tasks. So based on the challenges and based on the interviews we conducted with the healthcare professionals, we identified 10 design requirements for like I'm not able to expose all the design requirements and analysis goals due to the NDA disclosure that we have signed up with. So that's the reason I'm not able to expose those requirements and analysis goals. But of course, maybe in the next presentations, I'll be happy to discuss much more in detail. But at a high level, when we are doing this kind of research, I just want to share the idea. We captured 10 design requirements, followed by 3 analysis goals. So from the design requirements, we were able to capture analysis goals. By conducting again interviews, we were able to understand what are the real goals that we would like to have. And each analysis goal, we were able to extract almost 3 tasks. So in the third analysis goal, we were able to extract almost 4 tasks. So, and the tasks were completely based on the temporal features. It was based on the individuals that could play a role. And the third was on the content. And fourth was on the threaded based data. And we identified 2 data sets, and which was shared by a couple of healthcare industries. I'm not in a position to expose that information again due to the NDA disclosure. So we received 2 data sets and 3 case studies again from the couple of hospitals. Again, I'm not able to reveal those information because it's being recorded. Yeah, so this forms the discovering stage. To have the design requirements, analysis goals, tasks, data sets, and case studies. This forms the discovering stage. Once everything is set up, then it's all about diving into the designing. So the stage 5 and 6 is all about designing and implementing. As I mentioned earlier, we started classifying into 3 types. So phase 1, we call it as temporal analysis. Phase 2, we call it as individual analysis, and phase 3, thread analysis. We started building solutions focusing only on the temporal features as a phase 1. At later stage, we try to merge all the 3 things, so which forms a complete solution. In phase 1, we identified the challenges which were completely part of temporal features. We identified the design requirements, followed by analysis goals. So we had 3 goals, as I mentioned, and tasks. And when we started developing a prototype, we always focus on low fidelities, medium fidelities, and high fidelity, which I will explain you in the next slide. So that's the design process. In the design process, it's always good to start something like a low fidelity. So what do we mean by low fidelity prototypes? Just take a paper, take a sketch, take a pen, just start drawing something. It could be like a bar chart. You try to access some data, and what happens from there, you try to show some arrow marks. So that's nothing but a paper version of it. So that's called low fidelity. It's always good to start something on a paper, then transfer the whole thing into a medium fidelity. Medium fidelities are something like you have IBM Watson, you have Tableau, where you can quickly build some solutions within a couple of days. Once you have a concrete idea of your design, and once you have some paper sketches, then it's quite easy to build a quick solution. That's the medium fidelity prototypes for you. And the third is the high fidelity prototype, which you'll be really deploying in a real platform. Let's say that you have your own platform, or you're working on a collaborators platform. You start building from scratch. You start understanding the libraries that are required to build certain visualizations. In our case, we use something called d3.js. That's the library that we use. And to use that, we need to integrate a lot of other libraries, call various functions. So you start building that on real time and start deploying that in your collaborators platform. So this helps in discovering the information within a data. Let's say a particular information is being hidden due to various reasons, because visualization doesn't help you quickly to get all the data or all the information. So you need to navigate through the whole process. Then that's where you discover various interesting and relevant information. And so as I mentioned, we started with phase 1 with the focus on time. Once we were able to identify some interesting aspects, so we started moving into the phase 2, and then that's where individuals came into play. It could be healthcare professionals, nurses, and the patients themselves. And then we moved on to the threads. That's where the threaded information where we were able to access. We were able to understand a patient's management plans, patient's history, and patient's other health conditions. So that's how we moved from one phase to other phase to other phase, and we started deploying it in each phase. So we call it as Redshift platform. So that's one of our collaborators platform. So every time we completed the high fidelity prototype, which was ready to be deployed, we straight away pushed the whole solution into the platform. Then from the phase 2, we pushed the solutions again, and we had a complete integrated solution. As of now, it's completely integrated, but of course, there's a lot of refinement that need to be done. And in every phase, we were able to identify some findings. We were able to capture various observations, which we always made note of, so that was helpful for our phase 2. And from phase 2 was one of the base for us. So from the base, building on something was really helpful. So every phase, we need to focus on the findings and the observations, which is really important. As researchers, I would strongly suggest to focus on observations, make a lot of notes every time you conduct research, every time you design something, every time you develop something. Always make sure that you jot down the points. So that really helped us. So we were able to push it to the organization collaborators platform. So in the design, of course, in the design phase 1, so I call it as DV. The DV is nothing but design and validation. So that's nothing but the phase 1 of the design solutions. So, as I mentioned, we started with the temporal analysis. So this is how it looks like. So this is the complete temporal solutions. Healthcare professional can directly get into the visual software. He can start identifying based on the years. The bar chart helps in navigating to the whole data. Let's say the doctor is very much interested to know a patient's data a couple of years back. For example, in 2018, what exactly happened. Then he clicks on the bar chart 2018, and then he sees the patterns that has happened. If he's interested, he'll be able to understand at one point of time the patient had suffered with a lot of sickness or any other particular health conditions. It could be it could be a complete blood loss as well, for example. So you will be able to understand at what point, what instant of at what instant of point these things have happened. If you want to filter down further, then the healthcare professional can further filter down. It could be in terms of month, it could be in terms of days, it could be in terms of hours. So we call it as a granularity, right? So it starts with a year, followed by a month, then the days, and then the minutes and the time, and it could be weekdays or weekend. So that's how you completely granularize it. So whenever you are interested in a particular month, the healthcare professional can click on the particular month and again observe the patterns. So this is completely on the temporal feature. Once we were confident that these things are quite good, we try to move into the phase 2. That's nothing but the individual analysis. So in the individual analysis, we were able to identify which are the consultants or which are the healthcare professionals who played a role in a particular individual's health records, or who has managed the records, or who has managed the patient's conditions, who has monitored, who has jotted down the notes. So we were able to track this information. So let's say a healthcare senior expert or a consultant who's interested to observe some various notes. You can click on a particular individual and see the notes actually. And the bubbles represent the number of information being recorded by a particular individual. So this is a very simple solution, but it's quite effective actually, especially for a healthcare professional. This makes a massive difference in terms of analyzing the patient's data. Once we were confident about the phase 1 and phase 2, we moved into phase 3. That's nothing but thread analysis. In the thread analysis, we were able to identify what type of data or information has been recorded. You can see at your right side bottom, you can see the patient's notes and data being captured. At the same time, you have different kind of visualizations where we call it a single thread view, multi-thread view. So single thread view, it could be just a very simple condition. So we call it a simple thread view. So there's a small thread and then it stops at some point. Whereas multiple threats, you have a cross relation between multiple conditions of a patient. And that's where you start comparing with the multiple threats. And the interesting part of threat analysis is we have started using active learning. If a healthcare professional is interested in understanding what would be the future conditions of the patient, he starts monitoring the patient by circling some of the conditions that the patient has. Then he starts predicting, saying that this patient can be exposed to some kind of a drug allergy, for example. So it starts giving you some kind of predictions based on the patient's data. That's the threat analysis. And once we were done with the deployment, once we are done with the complete implementation, then it's all about deploying it to our platform's industrial collaborators platform. So we call it as stage 7. And stage 8 was nothing but reflecting on whatever we have done so far, and still we are in the reflection stage. Stage 9 is writing, which I will explain you now. In the stage 7, it was, as I mentioned, it's about deploying the solution in the industrial platform. It is very simple process. So we started collecting the data, we started archiving it, we started classifying the data based on the design process that we captured, and we started clustering and computing the data, followed by analyzing the data, then building the solutions, and everything was done completely on the Redshift stream processing platform, which is the industrials platform. As I mentioned again earlier, in stage 8, we need to reflect on whatever work we have done. It's a very iterative process. We cannot just say that we have done with something, we just deployed a solution and the healthcare professionals are quite happy about it. And I think that's not the end of it. It's about reflecting and improvising on a constant basis. And in that aspect, as we defined the objective 1, we were able to reconfirm iterative user-centered design, which means we were constantly discussing with the experts, healthcare professionals, and the industrial stakeholders, academic professors. So we can confidently say that this kind of a iterative user-centered design approach gave us a very good base to capture requirements from the experts, which helped us achieve objective 1. And in the objective 2, again, it gave us a very good platform to build and design solutions, which is also part of user-centered design. And the third objective was about validating the solutions, again with the experts. The healthcare professionals were quite happy because we were able to demonstrate what was their requirement, and we were able to show them that kind of capability in whatever we designed. So that forms our objective 3. This is how we were able to reflect constantly. And again, the most important part of the whole research, or in terms of developing solutions, is about findings as well. So, and it's something very similar to the objectives. So use an iterative user-centered design helped us in understanding the domain as well as the investigation needs for a healthcare professional. E-discovery is something which I didn't want to bring this topic, because this is something to do with compliance of healthcare compliance. We call it as e-discovery and digital forensics. So I don't want to bring that topic into this picture because I'm not supposed to expose that information for now, but of course I will be able to explain sometime later. So what I want to say is, in the terms of findings, we were quite happy with the way we were able to conduct the user-centered design approach. And the other finding was multifaceted exploration. When you integrate time, individuals, content, and the thread, that forms a multifaceted exploration. If a person is interested in time, then he starts clicking on the particular time of interest, and then it starts demonstrating what exactly happened with the patient, who are the consultants who were part of, and what kind of history notes or management plans have been taken. So that forms a multifaceted exploration. Multi-granular is nothing but you break the time into different forms. That is, you start breaking them into years, months, days, and minutes, seconds. It could be weekdays, weekends. That's completely called as multi-granular analysis. In terms of finding 3, we can say that we developed something called visualization assisted active learning approach. This helps in classifying the communications that have been taken place between patients, consultants, and other professionals, other healthcare professionals. So these are the 3 findings we were able to capture. And in terms of learning, it's for industry people, generally, they don't believe in documenting these things, but I personally believe it needs to be documented for a better research, for better improvisation of research, so that your collaboration gets stronger and stronger. So this is what I strongly believe in. And so, as I mentioned, once we started reflecting on it, we also had some learnings. So we thought we need to work further with the healthcare professionals due to time constraints. And of course, this year we have been severely hit with the COVID. We were not able to discuss lots with the healthcare professionals. But of course, considering the next year, we'll be discussing more with the healthcare professionals. So that's one of the learning from this whole process. We need to focus on the specific requirements and identifying the conventional or traditional visualizations with innovative visualizations or novel visualizations. We need to carefully analyze and choose. The reason is, as I mentioned, healthcare professionals are not tech savvy. They'll not be able to quickly adapt to the latest visualizations or latest platforms. So we need to hit the balance between something innovative, something novel, and something traditional. So that balance we need to really hit. And we would like to conduct evaluation with the non-experts, which means it could be users, it could be patients. So that is also in the agenda, so which we'll be doing in the future. And to contribute better to the academic research, we thought it might be wise to come up with a lot of principles, whatever we observed, whatever we made notes, whatever we analyzed, whatever solutions we have developed, and the evaluations that we have conducted. So we came up with 7 principles. The principle number 1, we need to focus more on the domain specific requirements if you want to make it as a very strong solution. Principle 2, you need to focus on iterative user-centric design throughout the design cycle. You cannot leave a healthcare professional at some point, because this year we were hit. So this is one of the lessons that we learned. We cannot leave the person out of the loop. You need to have the healthcare professionals throughout your research, throughout your deployment stage. So that's one of the principles. Third, you need to use some kind of a latest feature engineering techniques or something to extract more data, more information, or more patterns. In fact, that's what I mean to say. Use better techniques to extract something out of the data, because if your data is unstructured and it's not very neatly packed, then it's going to be a real tough task to develop some certain solutions quickly. So we need to develop some kind of feature engineering techniques there. That's principle 3. Principle 4, you need to build pattern-oriented interactive visualizations if you want to identify some interestingness in the data of a particular patient. For example, let's say a person has a cancer and he wants to, if a professional wants to really understand what exactly happened, some interesting notes that being captured by the previous doctors or other healthcare professionals. So then we need to have some kind of a dynamic and interactive visualization that can quickly flesh out those kind of interestingness. And in terms of principle 5, we need to have both multifacetedness and multi-granularity in the healthcare data. The reason is the healthcare data comes with time, individuals, content, and threats. So it's always good to use multifacetedness. In terms of multi-granularity, it's again good to break the time into multiple granulars. As I mentioned, years, months, time, hours, weekdays, weekends. So it gives you a better way to explore the data, and you'll be able to discover some interestingness in the whole data. In terms of principle 6, it's very important to demonstrate or represent the evolution of the data of a particular patient. That's where you understand what happened in the past, what's happening currently, what can potentially happen in the future. So that gives you a very good space to understand the evolution of the particular patient's data. And as principle 7, we try to close the principle in terms of evaluating the whole system with both the experts and non-experts. Let's not stick only with the experts, because you need some kind of information even from the non-experts that gives you a better validity. And the final stage is all about writing. It's about contributing something towards the society. It could be contribution to the healthcare system. It could be contribution to the academic side. It could be in various forms. And the things that we identified, where we were able to characterize the domain, we were able to get the problems, we were able to get the tasks for the healthcare 5.0, which is something really important if you want to build some solutions. We were able to identify the knowledge gap, and we were able to also identify the techniques, existing techniques that people have done for 3.0 or 4.0. Currently, people are working on it. So that gave us a better edge to develop some quick solutions. And in the third point, building interactive solution, validating the solutions, deploying in collaborators platform. We use Google Suite. So we try to push using the Google Suite for now, but of course we need to make some changes there. We also gained a lot of learnings and we contributed as principals. So this all forms as a contributions. We'll be presenting more papers and we'll be filing a patent in the US. So that's one of the reasons I'm not able to expose more information, which I would really love to do. So yeah, that's pretty much about all the 9 stages of design study methodology that you can use for healthcare 5.0. And yeah, I think I've covered all the stages that we have done so far. And just quickly to let you know about our company, MIT Square, we work on incubation startup companies. If you have any ideas and interests, we'll be happy to support. It could be a cross collaboration from UK, India, and Australia, of course, from US as well. We do support a lot of research and innovation fundings. We do encourage, a collaborative kind of funding. We have one funding from IBM. If you folks are interested, we can work together again on the healthcare side. And if you have any undergraduate or master students who are interested in internships, we are happy to support. And patent filing in Australia, we do support. In UK, India, we have consultants who can support you with the patent filing. And yeah, that's pretty much. We support with any design and development from industrial sectors, manufacturing and supply as well. We have presence in Australia, which we are closely collaborating now. And we have office in India, UK, as well as in US. We are focusing on various disruptive technologies like IoT, embedded systems, artificial intelligence, ambient intelligence, blockchain, cybersecurity, robotics, patent filing, and entrepreneurship related solutions. And we have other offerings of, like, it can be a joint program between Australia and UK. It can be faculty development programs, student exchange programs, joint PhDs. I'll be very happy to be a part of the whole activity. I'll be happy to serve as an industrial mentor if needed. And any other courses that you are interested, integrated courses with the latest technologies, we'll be happy to support. And yeah, I would like to say thanks, and any questions, I'll be happy to take it from now.
Thanks for sharing your experience and knowledge on design study methodology, Dr. Mithileysh. And that's a diverse amount of experience as well as the services that you're offering. Thank you so much. And it is an amazing talk. Yeah, from what I understand, the design study methodology actually shows us how the research outcome can be taken till the end, in line with meeting the objectives at each level of the study. And yeah, we received a few questions that we can start having a discussion now. In the meantime, sure, if someone has questions, yeah, they're welcome to actually use Q&A and ask, or just raise their hand and we'll be able to unmute them and they can talk, or we can just add them to the panel. So the first question that we have here is, this is from one of the PhD students. I can connect the dots backward in my research work, then quantifying or recognizing the current research phase I am or the future progress. How do you think this could be efficiently handled while prototyping a product? So the question says that.
Able to see the question actually.
Oh, I can just put it in. Someone's just sent me in the chat. I'm just keeping the question in the chat for you, I think. Can you please read that?
Yes, I'm able to see now. So I can connect the dots backward in my research work that quantifying or recognizing the current research work phase. How do you think this could be effectively handled while prototyping a product?
What I understand is, like, at the stage of their research, like when they think backwards, they can understand how this could have been done better in a way in retrospect. But when it's actually in the current stage where they are, probably it's a product or patenting kind of research, entrepreneurial research, where they're trying to find better understanding of.
I see it as 2 ways actually. When I was doing my PhD, that's always there. Like you try to think as the technologies evolve or solutions keep evolving, or you that you want, it would have been better if you added some new things to your research work. But in reality, sometimes it's no. The reason is, let's say Samsung develops some solution or a app. They first try to push it, they release it, then they have version 2.0 or 3.0, and they continue to go on. So you retrospect, get some feedback, try to work on it, try to push the new solution into the system or into the market. So in terms of your PhD, it's fine. Once you started moving in the same direction, try to make sure whatever you think that you're missed out, If you have time, you try to address them. If not, try to keep it as a future work. Tell them that you analyzed at this point of stage, but you'd like to address in terms of future with proper citations and other things, why you think that you missed and what you think that you can do better in the future. So that clarity, you can bring it in terms of your research.
Yeah.
So did
It's
I
an
answer
amazing.
the question?
I guess so. I'll ask the attendee to ask more questions if there is anything based on that doubt.
Definitely.
And so there are a couple of questions in the Q&A tab, which you can also see, I guess. So the first one is, with the data challenges in healthcare industry, example, getting COVID patient data, how can we identify the design patterns?
Actually, we have not worked anything on the COVID related data so far, but of course we have a lot of plans for it. Due to the sensitivity of the data, we are not in a position to do anything much. But in terms of understanding the design patterns, what we are doing currently is about only the history and the management plans, what doctors have recorded in their platform. So we received a couple of information, in fact, the very big data set from a hospital where they had a lot of management plans, health conditions of a patients. So we were able to observe the patterns in terms of a time, like when a person's conditions were really normal, whether during the cold seasons or whether during the other Christmas time, or it could be during the morning times, evening times, or afternoon times. So those are the design patterns that I mentioned in our work. But of course, when you bring in the COVID data, that I think the whole thing might change. So we need to see how it works.
Yeah, I totally agree with that. So there's another question, which is, could you please elaborate on building medium fidelity model using IBM Watson Health?
Okay, using IBM Watson, I think they do provide you with a platform where you can just dump the data, whatever you have, into the system. Along with Noor, we'll be organizing another seminar or webinar along with IBM folks. Those guys will exactly tell you how to use the IBM Watson, how to get login to the system, how you can push the data, how we can start analyzing the healthcare data. So that's going to be really interesting next month. I'll closely work with Noor, and we'll make sure something really happens with IBM, and you guys can attend for sure.
Thanks, Mithileysh. Yeah, of course, we would love to host it. And next is, how do you incorporate active learning into your framework?
This is
I think
where is this from?
So this is again from one of the attendees. So I'm just putting it in the chat. So basically they have just typed it in the chat, and that reaches to the host. So.
Okay, so how do we incorporate active learning? So what we did, we use something called data-driven documents. Have you heard of D3.js? So that uses JavaScript, HTML, and CSS. So maybe I can type it for you guys. So maybe you can look into it. It's called D3.js. So please have a look at it. So this is one of the front-end framework that we used, and the backend, of course, you need to use SQL, and then to build any visualization, not visualization, in terms of active learning or any machine learning techniques, you need to use Python. So we connected Python and the SQL as a backend behind, and the front end was completely JavaScript, React, HTML, and CSS. So that's where we try to plug in the whole framework. And once everything was set up, it was easy for us to push it into the industrial collaborators platform, because they have that kind of facility to push one for the back end, one for the front end. So that's how we try to incorporate.
Yeah. Thanks for explaining the details, actually the practical implementation details. All right, I think that's the end of the Q&A session, unless someone has raised a hand. I think no, those are the questions. So, all right, I think we are pretty much done for today. Yep, thanks to the speaker, Dr. Mithileysh. Also, we can hear a very slight voice of the baby in the family. Please say hi from Victoria on behalf of all the attendees. And yeah, thanks once again for the kind cooperation during the talk. Thank you.
No, thank you so much for the lovely invite and organizing the whole event. This is fantastic stuff.
It was our pleasure. Thank you so much.
You have done fabulously well. So continue to do so. And if you require any collaborative support from any industries, and of course any across the globe, please let me know. I'm happy to support you in any aspects.
For sure. I'll share your address and the details with everyone who is attending here. I have also actually shared your LinkedIn profile too. Yeah. Also, thanks to the wonderful audience and the event organizers, namely David, Emerson, Lucas, Paul, and Jan. They have been helping with the promotions. Thank you, guys. And it is a great pleasure for the University of Melbourne Student Branch to organize this talk with their support. We'll be sharing the recording of this session soon in 2021. Yeah. That wraps up our event for 2020. Thanks everyone for your support and Merry Christmas.
Paul. Thank you, Paul, David, and Emerson. Have a fantastic, Christmas. Enjoy yourself with your families, and we'll catch up again soon. All right.
Sure. Thank you. It was nice to have you.
It was nice talking to you. Bye.
Bye.
See you.